said he was going to do it. But it's one of those things. All right, that sounds like quiet. You guys are all really quiet, so welcome to Hacker Society.
Okay, hi, I'm Dina. So who here, like with a show of hands, has bought your link state tickets?
Who knows what Link State is?
Can I try to?
Ooh.
Oh, that's good.
Yeah.
Okay. So
Can I
Link
try
State
that?
is our annual fall tech conference. It's on October 3rd.
Yeah.
And basically what you do is it's on Saturday and it's a whole day of different tech talks that you get to go see. $5 will get you food, cool swag, and you get to hang out with all cool people like us, right? So yeah, if you go to acm.case.edu, if you scroll down, you'll find like the state conference link, and then that'll take you right to the, like you'll find a web frame of the Eventbrite, and that's where you can buy your tickets. So yeah, I highly recommend. It's super awesome. You get to chill out with all of us in Haymarket Atrium and like Schmidt, where all your classes are, so that's fun. But yeah.
Who's speaking?
We have some pretty cool people who are not
totally confirmed yet? Do we have anybody that we can secretly maybe announce? No. Okay. Next time. Next time.
Next week.
All right, next week. Okay. Another note, as you may have gathered or may not have gathered, I am the one, Tim Henderson, who schedules these meetings, as in like figures out who's going to present and what the talk is going to be. However, next semester that could be you if you are a sophomore or a junior. Freshman, good for fall of 2016. So, if you'd like to schedule spring 2016, please talk to me. It'd be great if you did it. All right. You can also email me. Are we ready? Are we prepared? Or shall I pontificate on about something else?
If you'd like to pontificate, please do so. I will give me just 1 second.
Okay.
And that will be.
Are you guys ready?
Yeah, I can.
You want to go?
Should we go now instead of?
Okay. I'll give you 1 minute,
All right,
and if you haven't figured out your computer yet, we will switch over to the next slide.
Okay.
Is the projector on?
Yeah, it's. Where?
Projector on. Well, the projector warms up. Okay.
Yeah. Okay. Is that what's being shown?
It's here. So
Is
you're
it?
connected.
Yeah. Okay.
Okay, great. Looks like his laptop is connected. This is coming on. I think one of these lights. I don't know. Oops. That's too much. Ooh, there we go. Okay. Perfect.
Okay, cool. All right, we're gonna try to make this somehow. Hey everybody, my name is Yidi. I'm a freshman computer science major, and I'm gonna talk a little bit about Sublime. So Sublime is my favorite text editor, and here's why. So here, let's first open up Sublime. Okay. Subl is the command line command for opening up Sublime. Okay, cool. And you'll notice this link was already on there when I opened up Sublime. So here's the first thing that I want to say about Sublime is that it saves your state regardless of whether you actually save the file or not. So, you know, that's the first thing I really like about Sublime. Anyways, let's check out the website. All right. If I can open up a web browser. All right, cool. All right, here's the Sublime website, sublimetext.com, and then you can download it if you click download. There are two versions of Sublime currently released. One is version 2, which is I think the last time that they updated it was here 2013. So it's a little bit out of date, but it's entirely stable. However, Sublime Text 3 has been in development for I think probably 2 years now. And I recommend if you're going to get Sublime Text 3 because it has a few different a few extra features from Sublime 2, and all the plugins or all the packages, which I'm going to talk about later, that are available for 2 are now ported over to 3. So here you can download it for OS X, Windows, and Linux. All right, let's just close this. Okay, so cutting back to Sublime. So let's start by building a Sublime project. And so we can come here and say save project as to create a new project. And let's just call this Sublime Lightning. Let's save it here. And so projects are the basic unit of organization for Sublime. And so when you open up a project in Sublime, it'll save the files and folders in that project. It'll save a few build properties for that project. And then, so let's add a folder to this project. We go to project, add folder to project, and I made a folder called hacksock that for this talk. So here we have what's called the Sublime sidebar, and then that shows all of the folders that are in your current project. And then as you can see here, there's a little icon here next to the Python file, foo.py. All right. Yeah, it just died.
Oh, well.
Okay.
Sublime Text.
Yeah.
Great text editor.
Get Sublime. I didn't do a great job of advertising it today because my laptop died, but
No, you did a great job. All right, let's move on to Python. You should definitely check out Sublime for the market for a good Windows, Linux, Mac text editor. Next time we are going to hear about Vim from Andrew of OnShift, which is another text editor.
Let's see how this goes. Okay, cool. Oh dear. Having some display issues, sorry. How does it look? Cool, that looks awesome. I can live with this. Alrighty. So, hi, I'm Jeff. I'm a senior computer science major here at Case, and I'll be giving a talk on basically a crash course on Python, both a little bit information about the language and how to actually start using it if you're not familiar. So, what is Python? I mean, when people throw the word Python around, they're usually referring to one of three things. They're either referring to the language, like the actual programming language Python, the ecosystem, which is part of a larger developer community and a bunch of packages around it, and the active development that's going on at this very moment, most likely. And then finally, a sort of like lifestyle, a way of thinking about code and a way of writing code that has sprung up around Python, the language, and the ecosystem. So Python, the language, the Wikipedia definition is a multi-paradigm, high-level programming language. So something that's pretty flexible and pretty abstract. It features strong dynamic typing, so that means from a programmer's perspective, you don't have to specify types, but under the hood, it's more rigid. Things are very explicit behind the scenes. With the Python as a language has an emphasis on terse but readable code, so it's very short, but you get a lot done with very few lines of code. And there's also a philosophy around batteries included with the language and the libraries, so being able to just get off the ground with what you've been given already, being able to fire up your laptop and just start doing work. There are multiple implementations of the language, but when people talk about Python, they're generally referring to CPython, which is the reference implementation that's available on a multitude of platforms. So a common question I get when I say that I know Python is, should I use Python 2 or Python 3? And usually followed up by, well, what are the differences between Python 2 and Python 3? And just to be brief about this, they're close but not equivalent versions of the same programming language. So there were some incompatible changes made between 2 and 3 that removed some cruft, some really nasty things, some things a little bit more minor. But for example, they added a print function and removed the print statement going from 2 to 3, fairly minor detail. They cleaned up the way Unicode encoding with strings worked, so it's much nicer from a developer's perspective and much kinder to people who don't use ASCII strings. And most interestingly, they made true and false keywords. Because back in 2.7, that was valid. So as you can see, that's a problem. So in general, you should be using Python 2 if you need it for legacy, but otherwise use Python 3 for newer projects. Most packages are caught up to Python 3 in the new language and all of its nuances. So, all right, second part, Python the ecosystem. Yes?
Could you put down the projector thing that the speaker, not the projector, the URL? Yeah,
This thing. This thing? I don't know how to put it down. So, like that. Oh, that's beautiful. Okay. So, Python the ecosystem. Huge standard library, and if that doesn't suit your need, you have pip plus PyPI, but I don't want to spend too much time because that's Steven's job later, and that would be mean. So, finally, there's Python the lifestyle. I suppose Python the lifestyle is a little bit vague. So, if you were to run Python 3, the best, the sort of Python lifestyle that I'm trying to describe is codified in the Zen of Python, which you can find in, yes? I'll maximize it. Is that visible? Okay. Like that. Cool. So this is sort of describing the philosophy around the Python language and how things, the way that code should be, at least within Python realm. Explicit key lines being explicit is better than implicit. Readability counts. Special cases aren't special enough to break the rules. Errors should never pass silently unless explicitly silenced. And there should only be one, and preferably only one, obvious way to do it. In general, this sort of philosophy has built a term called Pythonic, which is used to describe idiomatic and generally good, pleasing Python code. It's sort of hard to describe, but you recognize it when you see it. Generally it's looking good while still getting things done, and it's something to do with using the language to its fullest, both in terms of features and what the standard library has. But that's something that you acquire after spending a lot of time reading and writing the code. So now, if you want to go about using Python right now, you don't already have it set up on one of your systems. If you're running Windows, you can go download the installer and then just run it. It'll take care of everything for you. It's nice. If you're running OS X or if you're running Linux, you just use a package manager. You can build from source if you really like the challenge, but I'd recommend a package manager. And then for a workflow, most IDEs have a Python mode or a plugin, but a text editor and a shell works fine. So that's what I'll be using here tonight. So, all right. With that out of the way, I'm going to move on to how Python actually looks like and start writing some code for you. Let's see. I'm trying to make this terminal so that it's visible. Bear with me a moment. Cool. I might run off the side there, but I'll fix that when that comes up. So, the syntax for Python is somewhere between C and pseudocode. So I think because I mentioned C, yeah, I know, right? It could be anything, but I mean like liberatory sort of pseudocode where it's more Englishy as opposed to more like code, or more like English and math than it is like actual standard C or Java. So the canonical example for a beginning program is Hello World. So I figure I'll start with that. In Python, it can be as simple as a one-liner. So print hello world. We'll save it. And then we'll come over here, hello world.py. Yay! So it worked. That's not a pretty good environment setup overall. But I introduced a couple of things here. So first off, the print function. You call this function to put something to standard out. The next thing I introduced here were strings. Strings in Python, generally you start them with single quotes, although you can also do them with double quotes. So this, for example, actually I'll need a plus here. With that. If I save that and run that, it'll give us the same exact result. So you can also use strings with double quotes on top of single quotes. And the plus operator you're familiar with Java, but you'll also see some other ways to manipulate strings throughout this presentation. But of course, like which one of those should you use? I mean, whatever makes sense. So if I want to make a really snarky hello world for some reason, like hello world, emphasis, save it, run it, and now you have added snark. In that case, it made more sense to put the double quotes around the entire string, and then when you want to put the quotes around world, you just use the single quotes that you had originally desired. So that's useful for things like database queries where you'll have very specific requirements where you want your quotes, and you can just throw those in there. You can just use the other type of quotes around the entire string, and it makes it a lot easier on you as a programmer. Language gets out of your way, if you will. Now, this isn't a totally perfect hello world, because if we were to import this module, as we'll see in a moment, import hello world, this code would run, which is like sometimes okay, but if you're working on global state, that's not really something you want to do, and you don't always want to be redefining things like connections and whatnot. So we'll add a line here that'll only have it run when this is the main module. So if name _name equals magic main, then run that particular line of code. As you can see, if we go over here and we run the module, it still runs. But if we try to import it now, nothing runs. So what I introduced here, first off, was the if statement. So it's sort of similar to what you've seen, but also got a few quirks. So first off, blocks are delimited with white space. So, or more importantly, blocks are started with a colon and then a new line, and then blocks are delimited with white space. So in here you are in, or I should say in here, because you can't see where I'm pointing. In here you are within a new block just because you indented further. You should be doing that anyway in your other programming languages, but Python actually makes you do it. And the way you can tell a block ends is if you indent down like that. Pretty straightforward. Another thing you might notice is that you don't need to have parentheses around your expression. You can just put it right there, and that's all fine. And actually, you don't even need a Boolean expression, per se. Python has this notion of truthiness, where non-Boolean values will get coerced to Booleans by a very clear, rigid process, which I'll walk you through just to make sure that you're somewhat familiar with it before you walk out of here. So in order to do that, I'll define a function. So here, you can define a function at a global level in Python, sort of like you can in C or C++, but unlike Java or C#, if you've used those languages. So def is truthy, and we'll have it take some value. And then let's see, we'll want it to return true if it's truthy or false if it's falsy. So what does that entail? A value is false if, let's see, is truthy. So a value won't be true if it's false. So if value is false, or value is not false, I should say in this case. A value won't be true if the value is none, where none is the equivalent of null, if you will, from other languages. is truthy will be false if it is not equal to 0 numerically. And then value, or is truthy will be false if the length of the value and equal length of value is not equal to, or is not equal to 0. So in every other case, the is truthy, the given value that you passed will be truthy. So in order to test this, we'll add a quick if is truthy true, print true is truthy. Exciting. Oh no, we got a traceback. But, so what's interesting here, and this is probably a good time to introduce the try except statement. So we're getting an error because we're trying to do, not the numeric comparison, but we're trying to call the length operator on, value, and in this case, not all types are going to necessarily support that. The first two comparisons where you say is not should be true. So if the value is not actually the false object and if the value is not actually the null object, that should be good. Not equal to 0 generally passes, but we'll throw it in a try except statement. This is going to be familiar for people who've used try catch from other languages, but in this case it's just try except because you're stopping exceptions. Except pass. And then if we were to run this again, we should get, yeah, true is truthy, which is exactly what we wanted to see. So that's roughly speaking what truthiness works in Python. That leads to some nice things where if you have a value that could be like one of either like an empty list or could be one of false, you can just put that actual variable name in the if statement, as opposed to just having to wrap it up in a function call that converts it to a Boolean or something like that. So a little bit of syntactic sugar there that makes things a little bit better. I should probably also mention that this try except will catch all exceptions. So if any sort of exception were going on in there, say like, I don't know, a Stack Overflow, it would catch it and then do nothing about it, which would probably be not necessarily desirable. And pass, I should mention, is a keyword that's just a no-op. It just the interpreter does nothing if it sees a pass statement. So it's kind of handy for just putting in something and then walking away from it. So let's see. Now I'm going to test this. I want to test this function is truthy with a bunch of different values. So in order to do that, I think it makes sense to use an if statement. So if I do, or a for loop, I should say, in false, true, none, empty list, 0, 1, high, empty string. And we say, I'll just steal this code, why not? We don't want to steal that code. Is truthy item, and we say dot item, or no, dot format item. So here, the interesting thing about for loops in Python is that they don't operate on, it's not like in C or C in Java where you have int, where you have some initialization step, some step that gets run every time you run the loop, and then some finalization should I exit step. In Python, for loops work on iterables every time. So iterables, like what are those? This could be a number of things. In this case, we literally just have a list. So these brackets denote the start and end of a list, and you have commas separating out each of the elements. This is just a list of false, true, none, open, close, empty list, 0, 1, high, and then the strings. But you can also have things that are generators. So, well, there are also things called generators, which basically they don't behave like a list, but they return values at multiple points in time, and you're able to iterate across them as though they're a list without consuming huge amounts of memory. So if you wanted to iterate from like 1 to 1,000,000, you wouldn't need to reserve 1,000,000 integers in memory, because that's just silly. But, all right, enough of me talking. Let's just run this and make sure that it actually does what it says I think it should. Yeah, okay, cool. So it only printed out things that are truthy. Oh, and then there's the string.format function call, which is just a way of taking an item and then throwing it string representation into the list. String representation being defined by each object type. Okay, so I've talked about for loops. I've talked about exceptions. Talked about lists and iterables. So I know this has been like wonderfully interesting so far, but maybe I'll try to do something a little bit more interesting. So, you know, let's see, maybe not Shakespeare.py, but insult kit, there we go. So before the meeting, I put together a list of, if any of you are familiar, the Shakespearean insult kit on web.mit, which basically you take an adjective from column 1, an adjective from column 2, and a wonderful noun from column 3, and you just stick them together, and or any combination or any choice from any of those columns together, and then you get an insult in the style of Shakespeare, and it's wonderful. But I want to walk through this example to familiarize you with a couple of the data structures and maybe a little bit more of the slightly more advanced stuff. So here we are in Shakespeare.py. So we'll start off this script just by taking what we know, and it'll just be run as a main function. It'll just be run as the main module, and then it'll just print out one random insult. So in this case, we'll need to import one module, random. We'll need to put our name main so that it doesn't get run every time. And then we need to actually build the insult. So let's see, we'll need to get a first adjective, a second adjective, and a third adjective. So, we'll also need to import from this other module. So from insult kit, import insult kit. This statement up here, if you look in this directory, we have insult kit co-located with Shakespeare.py. Or I should say insult kit co-located with Shakespeare.py. So we can import from this particular module, which is just a Python file in the simplest of cases, and then we can import a top-level module-level scope object from this module then. In this case, the insult kit dictionary, which has first adjectives, second adjectives, and nouns. So the simplest possible insult, I think, would be just to grab the first from each of those. Insult kit, first adjectives. What? I think it is. We'll find out, though. Through, all right. And then we'll just print, we'll add a quick little format. We gotta put thou at the front for the full Shakespearean effect. There we go. And adjective 1, adjective 2. Oh yes, good call. Thank you. Yeah, that would have looked funny. It was noun. Yeah. I think it's nouns though. Oh yes, that too. Cool. I'm glad that you, what? Oh yes, I'll need to close that. Yeah, I need a space there. Got too excited. Shakespeare.py. There we go. Thou artless base court Applejohn. But this is unfortunately not random. This is just fixed. So there is a function in the, there is a function in the random module that will allow us to just grab a random thing from a list. So we'll just do that instead of indexing into choice 0. Or even, I think is what my first guess might have been, choosing a random integer from 0 to n-1 and then indexing in. I think if you just use the choice function, it takes care of all of that. You don't need to reference the list twice, or in our case, the dictionary twice. And yet, if we run this a whole bunch of times, we find out we get a whole bunch of different insults. So it is random after all. Let's see. So I would like to make insults a little bit more portable. At the moment, it's a little loose with just like 3 words that are just floating around in module space. So I think it would make sense if we wrap them up in a class. So classes are sort of familiar with, or you're probably familiar with if you've taken 230 or 132, I think it's called here. What is it? Def. So we have the insult class and the intro to Java class. So we'll create the insult class where it'll take init. We'll have it take in a dictionary, kit, and we'll just have it grab each of these. We'll just actually, it makes more sense if I just go like this, and then paste a line, self dot. Yeah, I know, wrapped lines. Oh well. So we'll just have it grab those. And then we'll want to get the string representation out of this. And so we could do the string.format approach that we did down below, but I think it makes more sense to define a magic method. So Python classes in Python function like classes you are familiar with in other languages, in that you have a type and then you assign methods to it. But they're also a little bit different in that Python has a data model where you can get extra syntactic sugar from the language. That's how you can support do like operator overloading. If any of you are familiar with from C++, or I think C# might even have that these days. Where you can like override the plus operator from doing integer stuff to do like adding two things together. But in our case, we'll just do the string magic method, so that when we call the global string, like it's effectively the string method on it, it converts it to a string representation we can play with, sort of like toString in Java. So there's that, and then we'll return. We'll probably just copy this and paste that up here. I want to return it. Yep, that is good. So we'll just want to print insult. I'll just put the string around here for clarity. It doesn't really need to be there if it's going into a print function. What?
We need to pass things like kid chicken.
I will, yes. Good call. There we go. And what's this yelling at me for? Indentation.
Init is the constructor of the class, if you hadn't already guessed. And self is like this in Java. It's just a way of accessing the class's field.
Yeah, in Python they require that you put self before every class method, every one where you want to access the members of an instance. So mostly that's part of the explicit is better than implicit philosophy. And there's been a great debate about this actually, that you can read about on mailing lists. But in the meantime, let's see if this works. Adjective 1 is, yeah, it's because I forgot to do the self dots. That's okay. There we go. Thou conquered base court baggage. So I could sit up here and play with this a million different ways, but I figure that should be enough to get you all off the ground, at least playing with some basic data structures, the basic syntax, and things of that nature. So does anyone have any questions? I know this was a huge flurry of information, especially if you've never touched a language other than something like Java. Yes? Do you have a question, or are you just being pensive?
Where can they go to learn more?
Okay. So the internet. Python.org is it's the site for the Python Software Foundation. As you can imagine, full of information. The documentation section is, well, probably the place you want to spend the most of your time. There's the standard library reference, which talks a lot about what I described, although in much more detail. If you go from the introduction and work your way down as you need to for reference, you'll get a whole bunch of good information there. You can also do a tutorial if you're looking for something a little bit more like what I was doing, where it's interactive and you're learning it slowly, like less of the actual implementation details and more about here's how you do things. Stack Overflow, there's a Stack Overflow thread called Hidden Features of Python, where once you start getting comfortable with the language and you want to figure out what more you can do with it, let's see, I'm pretty sure I have it bookmarked. It just has a list of things that like you may not have heard of, or features that'll make you think of the way you're writing your code. You'll be like, oh, hey, I use that pattern all the time, and I could make it a lot easier. Argument unpacking being a pretty good example of that, but what that is a discussion for another night. So, yeah.
So you mentioned one of the great things about Python is it has all these huge libraries that come with it.
Yep.
So like, what are some of the libraries that we might encounter?
Actually, this is probably a great transition. So, if anyone else has any questions.
Save them for the end. Okay.
Yes. So, okay.
All right.
Oh, okay. That's right, because you can go to the website, and I trust you.
Yeah, I won't mess up your computer too bad. All right, how did we do the thing?
It should be set up. If you're lucky.
If I'm lucky. Cool, I'm lucky. All right, so we're gonna go to my website because this is going to be a talk that you're gonna want to refer back to. Not in the sense that it's so good, but in the sense that there's a lot of links. I think it's pretty good, but you'll probably decide that for yourself whether or not it's good. So yeah, you can find it right here, StephenBrennan.com. But I'm going to talk to you about basically what makes Python really good besides all of the cool syntax and all of the cool stuff that Jeff's been talking about. It's very fun to use as a programmer because it looks very nice and it's very easy to write a lot of complex things very simply. But a programming language doesn't really mean anything without having a lot of good tools that you can use to do things even easier. So now that you know Python, how can you make something cool? Generally, we make cool stuff by using other people's code. But we don't say that. We call it a library because that's a nicer way. That sounds like we're doing more original work. So I'm going to talk to you about how to use Python libraries to do really, really awesome stuff. And like I said, notes are there. So you don't have to take notes. You can just click links later. So first of all, the best Python libraries you're going to find, or at least the easiest ones to use, are the standard libraries. And for the record, this talk is going to be just walls of text here. And they're bullet points. I'm not going to explain everything because they're just links for you to click sometime later. But the best things you can use in Python are the standard libraries because they're on every Python distribution and they have a lot of useful stuff. It's a lot more than just Java's libraries where you say, I want to use an array list, I want to use a linked list, I want to use a hash table. Python's standard libraries are massive, and chances are there's going to be something there that you want to do that you didn't know was in the standard library. So collections is like your standard list. Regular expressions there are important. Random, like random.choice. We have just a ton here. And there's actually a list in the Python documentation of libraries that you might want to use. Jeff had it open earlier. This is a link right to it. It has a list of every single module in the Python standard library. It's a very long web page. And so whenever you're doing a project and you say, hey, I want to see if someone's done something, like I don't want to have to re-implement a binary search. Well, Python's already implemented binary searches for you. So you can just use a library for that. So that's my plug for the standard libraries. They're great. But sometimes there's something that you want to do that's not very easy with the standard libraries. And that's where we go into libraries that you get through Python packages using pip. So I'm just going to tell you, basically, pip is what's known as a package manager for Python. It downloads libraries. If you want to install a package, you use the command pip install whatever the name of the package is. This can be easier or more difficult depending on whether you're using Mac OS or Windows or Linux. Exactly how to get it all set up and running perfectly is a discussion for another time, but generally pip install works. These are notes for things like if you're on Linux and you don't have root, you can use this -- user option, which will install them locally for you. And virtual environments down here are very cool, but they're outside of the scope of this talk again. So all of these things you can do by just pip install Django, pip install Flask, pip install Tornado. So first, one of the strong points of Python is being able to do really nifty web development. That's also a strong point of languages like Ruby, but this is a Python talk. So like Ruby has Rails, Python has Django, and it's a very, very awesome web development tool framework that you can use to quickly make applications, web apps. So there's also Flask, which is a little smaller, Tornado, which does a lot of networking, and Pyramid is one that I'm not familiar with, but if you want to learn about Pyramid, talk to Tim. So web development frameworks will allow you to do cool stuff like make something like GitHub, make a cool app. I don't know what you want to do. You probably know better. But if it involves a web browser, these frameworks can help you out. Some things that might be useful for you, HTML templating. There's a module for it, and it's built into things like Django. Or Markup Safe here will give you the tools to escape HTML. So if you're doing like a forum, which you probably shouldn't do because people have already made a lot of those, but if you were making a forum or a comment system and people can enter arbitrary text in, you don't want them to start running bad scripts. Markup Safe helps you with that. If you're doing databases, there are some great modules for integrating directly with databases to make things very easy. This first one is an interface to my personal favorite database system. There's also in the standard library a database system that takes no effort to set up. It's just a file called SQLite 3. SQL Alchemy is a very cool database abstraction layer. So if you've ever used any databases, you've created tables, you've added columns to the tables, you've added entries, insert, update, whatever. It's really annoying because you've got all these strings with queries and it's a mess. SQL Alchemy is great because it basically maps all of that stuff to objects. Everything is like a Python class, so you can you can query things without using SQL by instead using functions on classes. It's a very neat thing to try out. I know Django also has a different object relational mapper, that's what that's called, built in, and so does Ruby, I believe, if you're into Ruby on Rails. Python has great libraries for web scraping. Requests is the best way to just download websites. If you need to, say, I don't know, download all of Taylor Swift's lyrics, that's a great way to do it is with requests. Similarly, say that you wanted to take those websites you downloaded and get just the lyrics out of it, not all of the HTML. LXML, a beautiful way to do that. Beautiful Soup is another module for parsing HTML, but it's specialized for when bad web developers write bad HTML. Beautiful Soup can help you out. And Scrapey is like a framework for making your own like web crawlers, sort of like Google has the Google bot. Moving on, Python has great support for testing. You have the built-in, I didn't even include it here, the built-in unit test module is just wonderful. You should be writing tests a lot when you write your own code. Nose extends the unit test framework in the standard library. There's a coverage module, which is perfect for seeing how much of your code you've written is actually being tested, which if statements you're not testing one of the branches of, which for loops you're not testing, all of these little things that are very important in learning test coverage. You'll learn a lot about that in 293, but coverage will help you out. Tox is very neat for testing your Python modules on different versions of Python in an automated way. And Factory Boy is like Ruby's Factory Girl, which is just a way to automatically make objects that are valid for you to do tests on, so very neat stuff there. Python also is just one of the best ways to do any scientific and research computing. You've probably heard of Mathematica and MATLAB and maybe Octave if you're into GNU stuff. Python basically one-ups all of them because it has a general purpose programming language that is very good. It has all the tools like multi-threading, multi-processing, regular expressions, all of the things you're used to in a first-class programming language, but it also has first-class support for numeric computing. It's great if you're ever doing any research, and these are the names of the libraries. I don't even know if I should get into what each of them does. But NumPy, SciPy, Pandas, Matplotlib, IPython, and SymPy are the core of what you would call the scientific Python framework. And through that, you can do just tons of high-performance computing very nicely in a dynamic, pretty language like Python. If you keep going through, there's even more science. That was just the base of the framework. Scikit-learn is a machine learning framework, very useful if you wanted to do anything that involves machine learning, research or otherwise. We have a very cool, well, that's not in Python, so never mind. NetworkX for doing anything that involves graphs, like the data structure, very useful. NLTK, similarly for natural language processing. Caffe, if you ever saw Google's Deep Dream pictures, yeah, those Deep Dream pictures were generated by Google using Caffe. Caffe is actually written in C++, so you can use it in other languages than Python, but it has very good Python bindings, and it makes it a lot easier to use than writing and compiling C++. It's a little difficult to install, though, so there are blog posts and tutorials on how to do that. In the world of just like random utilities, there's great support for great modules to support like coloring output to your terminal. Pigments is a syntax highlighter, which would be really cool if you were doing, I don't know, something like Stack Overflow where you need to highlight code or anything in between. I use it on my website to highlight code. NetAdder for IP addresses. Pillow is very cool. We're actually going to have a talk at Link State about someone who uses Pillow to do some pretty neat stuff with images coming right out of his backyard. You'll have to come to Link State to see that, though. And PyCrypto, because you should never be rolling your own cryptography, ever. If you do, I'll find you. Automation. Selenium is very cool. I wish I had time for a demo. Selenium will automate your web browser. You can open up a Python terminal, open up Selenium, start telling it to load pages, and you'll watch as to the side of your Python session, your browser pops up, a new tab pops up, it'll load the page, and then you can use the Python driver to start asking, find this part of the page, click that part of the page. It's just amazing for doing things like testing your website in a way other than just interacting with the Python code that you've written already. Selenium is amazing. Ansible, Fabric, and SaltStack are all different approaches. They do somewhat different things, but they're all about remotely managing servers. So say that you wrote an awesome web application and you want to deploy it. You probably want to be able to deploy it reliably. You could write a Fabric script to basically send your web application and set up your server entirely. Very useful. Tim has a lot of experience with Fabric and Ansible. I've used Fabric before. They're very worth checking out if you ever need to deploy things. And this is just a miscellaneous thing. If you've ever used Redis, it's a key value database. You can use that with Python. Celery is task queues. So if you have a website that people upload videos and you need to do processing on them, you don't want to do that on the same thread that you're serving a web request. So you want to offload those tasks to other computers. Celery is for that. PyParsing and PLY are both ways of making your own programming languages or grammars that you can parse. And Pygame is very useful if you're interested in getting into writing games with Python. Ooh, and I think we're coming about to the end of my list of libraries, although this is by no means exhaustive. If you ever decide to write much Python code, say a library, you should always be writing documentation, and it's something that we as developers kind of ignore a lot. Python has a wonderful tool called Sphinx that is great for automatically generating API documentation that looks pretty. And you can also use it with other programming languages, but you should definitely be documenting your code like this. All right, so that's basically the end of my list. In conclusion, I want you to keep in mind that the standard library is amazing with Python. You can do a lot. So you should take 5 minutes perusing that link whenever you start a project just to see whether you can use something in the standard library. You can always come up with a Python library that's useful if you Google it. And if you ever want to do research, you're talking to a computer science professor or a professor outside of computer science, and you need to be doing high-performance computing, Python is a very strong candidate, and you can also be using it for homework or for just your personal projects. And the last thing I want to say is that a lot of really cool project ideas can come out of going through this list saying, what would happen if I took this library here and combined it with this library? What cool stuff could I make by combining these things? What if I combined a Twitter client with a machine learning library? I don't know, maybe you'll start learning how people tweet. There are a lot of different things that you can do with this. So basically, Python is a language with a ton of features, a ton of library support, and hopefully this talk and Jeff's before it has given you enough resources to go out and find some cool things to use in your next project. Do we have any questions? Library recommendations, how do I install, anything like that? All right. Well then, thank you.
Does anybody else amused by the fact that the one thing is called celery?
Thank you.
Okay. Next week, we have our first talk by a company. So we have an outside speaker coming in. We have Andrew Wolf from OnShift, a local Cleveland startup. He's going to be talking about Vim, and which is a great text editor and will definitely change the way you think about writing things on your computer. So be sure to check out that talk. The week after that, Rob Wiesler is going to be talking about making closures in C and other bad ideas. So if you don't know what those words mean, you should definitely come to the talk and learn something. Even if it's a little above your head, I think that you'll all benefit from it. Okay, check out our events page for more. And if you're interested in helping to organize these meetings here, come talk to me. All right, see you guys next week.